Hello, welcome to our final interactive project presentation. In this video we will show you all of the process that it took to make this project called Pinturango. My team is formed by Jordy Beltran, Manuel Castro, Carlos Cepeda, Gloria Contreras, Luisa Gaytan, and me, KAMILA GONZALEZ. This project is a paint mixer. And how does it work? Well, the function is divided into parts, the color creation and the mixing part. So in the color creation, we will have 4 containers that will have different colors of paint, the basic colors, so that we can create any color of the scale or the basic color mixtures. And this works with some pumps that will be previously programmed to generate the color that we desire. And the mixing part grabs the container and then mixes it in 2 axes at the same time so that the paint is completely mixed and ready to use. Well, and you may be thinking, how did we got to this idea? Well, first we thought about it because many times we want a specific color and it is difficult to obtain it, or many times we get the wrong one. So we wanted to do this so that this problem disappears. We also thought about the money because these machines are very expensive, and this also saves a little money because of the materials. We thought about the efficiency, given that this process, as I already said, will give us the right color, and the mixing will be correctly made so we will have a paint that is well ready to use and with a great mixed quality. And we have the innovation because this machine joins 2 processes in one, and even though these machines already exist, they all exist as 2 different machines, the color creator that is also manual, and the mixer part that has a lot of difficulties to use because it is expensive, and it also contaminates the instruments with different colors of paint. We have some general objectives, that is to optimize the time of the process and the efficiency, as I already said, and we have some specific objectives to get done in the future, that is to create a color database, and for example the 2 processes in one machine is one of the main objectives as well, and to make it less expensive, and also in the future generate some smaller prototypes so that the local or small artists could get also their own paint, but that is another project that we plan to do in the future. And we also thought about this project in a social way. So the first one is that it will be made in Mexico, and in general these machines are always made in China or in another countries, or the pieces are bought in those countries, so they help the economy of those countries. And what we want to make here is to generate some Mexican products that will obviously help the national economy and the national businesses. This is also an employment generator machine for some reasons that I will explain later on. And this is also an eco-friendly machine because the processes that we use to get it done are not that contaminating, and it also reduces the paint waste because it doesn't need to be in direct contact with the paint, so we don't have to wash the instruments we use to mix it. And in general all these types of machine always get very dirty with the paint, and we will reduce the paint waste, that will reduce the contamination generated by paint. And well, as I said, this is an employment generator in some different ways. First of all, any businessman that has a paint store or that would like to get that color mix can get this machine and be self-employed so that the business can grow faster. And within 3 years the machine will be an employment generating project because of the growth that it will generate in the business, and this growth will be generated because of the time that gets reduced and the less expenses that it generates. Also because it generates more money because of the bigger quantity of paint that it gets made. So now my partner will explain you the design of the machine, and that's all for my part. Thank you.
Start with the part of the design. First, we have the final design that we get. To get this design, we divide our integrative project in 3 stages. The first stage is the one that is in the top, that has the water pumps, the base holders, the containers, and the hose. We use this formula to have the whole volume that we will have in the water pumps. The second stage is the one that is the structure of integrated project, that is made by frames, aluminum sheets, the top, the screws, bearing, the bearing holder, and the electrode. Here we have the example of the structure of integrated project that is made by aluminum profiles, and we have the example of the pathway of the welding. We made some analysis on the software of SolidWorks, and we have the result that if we place some force in the integrated project body, we will have some deformation. The third and the final stage is the one that is the clamp, and they have the conic gears, 5 bearings, and the screw, the level, the belt, and the motor. We select the conic gears to have a differential transmission and to have the lowest loss of strength. Also, we have the motor selection because we have the lowest consumption and we have the highest power in the motor. We have some other formulas to have the force that we will act in the integrated project with different ways in the bottles that we will place in the clamp. Also, we have the weight of the motor that is 4 kilograms, and we made the whole formula to have the forces that we will act in the integrated project body. Also, we have the density of the steels and the prints, so to have the whole weight of the integrated project. Also, we have the formula that we made to have the endless screw and the real wheel. Also, we have some structure squares, and all of these formulas are to have the whole forces that we will acting in the integrated project. Okay, finally we have the safety factor that is 3073. It is higher because we use the steel A30 that has the highest stress, that is 250 megapascals.
Okay, so I will talk about the manufacturing processes. Now we start with. We're going to use this squared aluminum profile for the structure, and we're also going to use this steel beam, specifically the A30, for the axis that will be rotating. These two are for the main structure. In other materials, we have first acrylic sheets for the doors, and also PLA that we're going to use it for the gears molds. And for the cylinder's base, we're going to use MDF wood. Now I'll talk about the manufacturing processes. So for welding operations, we chose a small process because we're more experienced. We're more experienced with this technique. We're gonna use either 4043 or 5975 electrodes, each one with a size of 1/8 inch and 2.5 millimeters, working at 160 amperes each. These two electrodes are special for to weld with aluminum. And we will cut the aluminum profiles with 10 inches cutting disc, as you can see in the screen. Also using the cutting machine that you can see at the screen. Now, for the assembling, we divided the project into critical parts. The first one is the press that's going to be inside our project, and the second one is the paint part. Here you can take off that cover, so you can have an easy access for the paint tubes, and so you can give it a proper maintenance. And here is the video of the assembling process. As you can see, the first part we have to disassemble is the press. This part that is gonna be rotating inside the project, and this one is the paint part. That one is the cover you have to remove to have access and finally other processes. Well, we will use the CNC, specifically the rough mill and drilling techniques for the cylinder's holder, that part, and the counter mill for the holder of the motor.
Now I'm going to talk about the CNC codes. We have two pieces that we are going to put in a machine. The first one is going to be the holder container. The process that we're going to have first is going to be the root mill in the place where the containers are. The second one is a drilling where the hoses go through. The next one is a root mill where the water pumps are. And the second figure or shape that we are going to have is the holder of the motor. The first process is a drilling where the screws are, and the other ones are a contour mill in both sides according with the shape of the piece, and a root mill where the axis is. Now I'm going to talk about the automation. First we have the controller. The controller we chose was the Arduino because we only need pulses to lead the program. We have buttons to choose the paints and to begin the process. We only need a controller that are working with low voltage and low amperage that are the Arduino. Also, we use the Arduino Mega that it has 52 digital inputs and 13 analog inputs. So they are enough to use to all the circuits we have. Then we have the electric diagram. As you can see, there is the Arduino Mega. We have the 12 buttons to the different colors and the buttons to the emergency stop and the start button. Also, we have two power circuits, one for the AC motors that is with a triac and an optocoupler to protect the Arduino to high voltage that the motor is using. Also, we have another power circuit made with relays and autocoupler to the motors to the paints. And the wires used in the AC motor is a 8-wire huge, and to all the circuit is going to be a 20-wire huge. Next, the security elements we have are the emergency stop, the push button. If there is any accident or there is any error, we can stop all the process in any moment. Also, we have two limit switches. One for the door that it has to be closed in the process, and for the press to hold the bottle. And the last one are suction cups to hold the bottle in a safety place. And the last one is the energetic consumption we have for the sensors and the actuators. The actuators are the motors, the AC motor, there is one, and the pumps there are four, and the sensors are all the buttons that we have: the emergency, the start, the color buttons, and the limit switches, and the magnetic sensors placed in the containers. We have the quantity, the individual voltage, and the total voltage of each one. Also, we have here the energetic consumption and the total consumption that we are going to have in use of 4 hours per day and 5 days per week.
To continue with the presentation, the next part is about sales. The first point is sales budget. With all the estimated cost, workforce, and marketing, the total cost of the project is going to be 38,722.75 pesos, and it is pretend to obtain a profit of the 40%. So the machine sales price is going to be 65,000 pesos. And if it is intended to export the product to another country, the sales price would be 70,000 pesos. And to see if Pinturango can compete into the market, a competitors analysis was made which determined that with its low price and the advantage of doing two processes with one machine is the best option. On the other hand, high tech includes a paint dispenser in its mixer machine, having in mind they are two machines and its price is lower, but the difference is the high tech dispenser is manual and Pinturango's is automatic. The next point is about national and international potential. This stage was divided into two parts. The first one is focused on getting the local market through local shops and expositions in fairs like Fenado. And within 5 years, the second part will be a shift that is to get the national and international market through expositions in fairs like Feria Nacional de San Marcos, which is one of the most important fairs in Mexico. And the last part is about scalability and limitations. The project is scalable because it is just a prototype and it is pretended to improve it in a near future. And also, to achieve other markets, it is thought to develop a scaled replica. And limitations are color spectrum and mechanism. As a conclusion, the project represents a good investment because being a prototype can compete into the market, and if the objectives are achieved, some improvement will be ready in 2 years. With this, we conclude the presentation. Thanks for your attention.